Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. We are discussing general wave properties for core and extended candidates paper 1. Okay, we have classwork. Please write down what you know, what you want to know, and at the end write down what you learned. If you would like to share your KWL chart, follow the Instagram account. Okay. Question number 1 here. We are discussing reflection. How waves behave in different situations. These waves, we have here water waves, how they behave when they find or when they strike a barrier. They have a solid barrier, they cannot pass through the barrier. So how do they behave? They will be reflected back. I will draw here the steps in details to show you how to draw the reflected rays. First of all, you have to follow the law of reflection. Waves will follow the law of reflection. This arrow is representing the direction of wave travel. So you have to extend this arrow. So it will strike the barrier at this point. You have to draw a normal line at right angle to the barrier. Okay. So this will be the normal at right angle. And according to the law of reflection, angle of incidence is equal to the angle of reflection. So the direction of the reflected waves will be in this direction with the same angle. So this will be the direction of the reflected water waves. Okay. The angle of incidence will be equal to the angle of reflection. Okay, what are these lines? Wavefronts. What do you mean by wavefronts? They are imaginary lines representing all crests or all troughs. So the distance between these two lines is representing the wavelength. The distance between these lines. That's why you will find wavefronts equally spaced. Okay. The reflected wave, the direction, this arrow is just showing you the direction. So this reflected water wave, you have to draw the lines, the wavefronts, and one of the properties of wavefronts, they are at right angle to the direction of wave travel. So if you have wavefronts, you will find that they are perpendicular to the direction of wave travel. So you have to draw here wavefronts equally spaced, okay, the same. So this is somehow shorter. Okay guys, I'm just drawing it roughly. Okay, so the direction, the answer, since we are here discussing paper 1, so it's not accurate. I'm just showing you how you can find your answer. So the correct answer here is C, because you have here the reflected water waves and you have here the wavefronts equally spaced. What happened here during reflection? Wavelength will be the same, unchanged wavelength. The speed will be also unchanged, and the frequency will be unchanged. The only change you have here is the direction of the reflected water wave. So during reflection of water waves, you will find only change in direction. Is it clear? So you can only change in direction according to the law of reflection. Is it clear, guys? Okay, so back to our questions. Question 2, you have here a plane wave. And actually, plane wave, what do you mean by plane waves? Because it's repeated in many questions. Sometimes we call it progressive waves or infinite number of wave fronts which are perpendicular to the direction of wave travel. So quickly, it's definition of plane waves. Okay, we have shallow tank, and we have here water of uniform depth incident normally on the small gap in a barrier. What happens after the wave passes through the gap? Okay, when you see the word gap or narrow gap, or you can find also expressions like sharp edge or barrier but it has a small hole or whatever, all these expressions is talking about diffraction. So what happens when the water, okay, you have here diffraction takes place during diffraction. What happens when the wave, they can pass through narrow gap like this? We call this narrow gap, and this representing width of the gap, or it could be only sharp edge like this. What happens? They change direction. Waves change direction. So waves change direction, and here also waves, they can spread out. Okay, so the waves spread out. So the answer is D. Okay, so the wider the gap, the spreading will be less. The wider the gap, the spreading will be less. We will discuss this later on in details. So the features now, what happens after the wave passes through the gap? During diffraction, all the features will be the same. All the features will be the same. Only change in direction. Only change in direction. Only spreading out. So the frequency, the speed, the wavelength will be the same after the waves spread out, after diffraction. Okay, so diffraction means spreading out of waves when they passing through a narrow gap or sharp edge. We will discuss it later on in details. Okay, question 3. Which statement is correct here? We have diffraction of wave on the surface of water. Okay, when they passes through a gap, its direction changes. Right, this one is right. Because we said diffraction, there is no change in speed, no change in wavelength, and the frequency also will not be changed. Okay. Here in question 4, also maybe we need to draw to show you what happens when water waves, they travel from a medium to another medium. How this could happen? Water travels to another medium. It's water already. Okay, if we have shallow water, we consider it a medium. If we have deep water, we consider it another medium. What takes place here is refraction. So what happens here is refraction. What do you mean by refraction? Refraction means that waves in general, any kind of wave, they change their direction and their speed when they travel from a medium to another medium. So we are dealing here with shallow as a medium and deep as if it is a different medium, but it's water already. Okay, which diagram showing a wave traveling from deep into shallow water, and it's mentioned here that shallow water, the water is slow, but in deep water it is fast. Why this is important? Because as we know, the wave equation, if you apply the wave equation, wave speed equals wavelength times frequency. During refraction, the frequency is constant. The number of waves passing from the shallow to deep, they are not going anywhere. We have the same according to the source, so the number of waves will be the same. So frequency will be constant. So if you have here shallow water, which means water waves moving slowly, speed decreased, so the wavelength will also be decreased. In deep water, if the speed increased, also the wavelength will be increased. Is it clear? Okay, so here which one we will choose? We have here this dotted line. As we said, construction lines, we draw them dotted. So this dotted line is not a barrier, it's a boundary. So the waves can travel through the boundary. So how the waves here will behave? They answer, we can exclude some answers, so it will be easier for you. So in shallow water, the wavelength will be shorter. So here, in shallow water, the wavelength, this is the wavelength, it's greater than in deep, so it will be excluded. Here, no change. Here also, no change. So the wavelength is shorter, is decreased in B. Okay, so you have to refer back to the wavelength, because if the speed is less, or the shallow water, the water will move slower, accordingly the wavelength will be also decreased. Okay, so slower, the speed is slower, it means the wavelength will be shorter. Is it clear? Okay. Question number 4 is very simple. We have circular wave fronts. Okay, according to the law of reflection, you have to exclude for sure A and B. Why? Because here we have a barrier. Barrier means the wave fronts cannot move or cannot propagate to the other side. Okay, so we exclude A and B. What about C and D? You have wave fronts, it had somehow circular, so they will be reflected also circular. Okay guys, so the answer is D. So they have the same shape, keeping the same wavelength, and all the features are the same, no change, only the direction. Question number 6. Question number 6, again here from deep to shallow water. The wave now enters shallow water and its speed decreases. Which row showing what happens to the frequency and what happens to the wave length according to the wave equation? You have here V equals wavelength times frequency. We said frequency is constant. So as they enter shallow water, the wave now enters shallow water. What happens? The frequency is constant. The speed is slower. The wavelength is shorter. So the speed is slower and the wavelength is shorter, decreased. Okay, so the answer for this one, that the frequency doesn't change and the wavelength becomes less. Okay, so the answer is C. Is it clear? Okay, question 7 is challenging. We have waves that travel more quickly on the surface of water when the water is deep. You know this information. you have a stone is dropped at a certain point, and the first wave front is drawn here. The region between X and which labeled point is likely to be the deepest one. Okay, we have X, it's representing the source of the wave, the place where the stone is thrown. And here you have the first wave front. What about these dimensions, these distance from the source to the first wave front? Okay, so this distance is representing the wavelength, right? Presenting the wavelength. So you can guess, you can estimate that in deep, the speed is increasing. So it's fast, moving more quickly. He mentioned in the question. So fast, which means the wavelength increased. Okay? So in this case, you will choose the answer of the longest dimension. The longest dimension. Okay, so the answer here, so you will not get confused. Okay, so the answer here is C. So why we choose C? Because it has the longest wave length, so it's representing the deepest region.
Subscribe for more videos. I love physics splendor. 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 I love physics splendor.